Now that you know what limit of a function is, may I give you the laws that governs operations and limits?
The limit of a constant function is equal to that function. For example, the limit of 5 as x approaches 3 is 5, whereas the limit of an identity function is equal to the value at which x approaches 2, like in the limit of x as x approaches 3 is 3. In evaluating the limits of a polynomial function, all we have to do is to evaluate the polynomial function at which x approaches 2. Say we have the limit of negative 2x plus 7 as x approaches 1.
Substituting 1 to the expression, we will have negative 2 times 1 plus 7. Simplifying that, we will have negative 2 plus 7. Simplifying further, we will have 5.
The next limit law governs when there is a product of a constant and a function. In evaluating such, all we have to do is to multiply the constant to the limit of the function after it has been evaluated at which x approaches 2. Let's work on this example.
Evaluate the limit of 2 times the quantity x squared minus 3 as x approaches 1. Substituting 1 to the function, we will have 2 times the quantity 1 squared minus 3. Simplifying the expression inside the grouping symbol, we will have 1 minus 3, which is equal to negative 2. Multiplying negative 2 by 2, we will have negative 4. Hence, the limit of 2 times the quantity x squared minus 3 as x approaches 1
is negative 4. In evaluating the sum or difference of two functions, all we have to do is to evaluate the limit of each function and then we perform the operation between them. For example, if f of x equals negative 3x and g of x equals 12x minus 1, find the limit of f of x plus g of x as x approaches 0. Applying the limit laws, we will have the limit of negative 3x as x approaches 0 plus the limit of 12x minus 1 as x approaches 0.
Evaluating the limit of negative 3x as x approaches 0, we will have negative 3 times 0. Plus, evaluating the limits of 12x minus 1 as x approaches 0, we will have 12 times 0 minus 1. Simplifying, we will have negative 1. Hence, the limit of f of x plus g of x as x approaches 0 is
negative 1. In evaluating the limit of a product of two functions, we will have the same approach just like what we did in the previous example, but instead of adding or subtracting, we will multiply the result. Consider f of x equals negative 3x and g of x equals 12x minus 1. Then find the limit of f of x times g of x as x approaches negative 1.
Applying the limit law, we will have the limits of negative 3x as x approaches negative 1 times the limits of 12x minus 1 as x approaches negative 1. Evaluating the limit of negative 3x as x approaches negative 1, we will have negative 3 times negative 1. Evaluating also the second function, we will have 12 times negative 1 minus 1. Simplifying each expression, we will have positive 3 times negative 13. Getting the product, we will have negative 39. Hence, The limit of f of x times g of x as x approaches negative 1 is negative 39. Now what if we are asked to get the limit of the quotient of two functions? Let's try this. If f of x equals negative 3x and g of x is equal to 12x minus 1, find the limit of f of x divided by g of x as x approaches negative 3. Applying the rule, we will have the limit of negative 3x as x approaches negative 3 over the limit of 12x minus 1 as x approaches negative 3. Substituting negative 3 to the function, we will have negative 3 times negative 3 divided by 12 times negative 3 minus 1. Simplifying, we shall have 9 over negative 37.
Therefore, the limit of f of x divided by g of x as x approaches negative 3 is negative 9 over 37. In evaluating the limit of an nth power of a function, we make sure that n is a positive integer and that the limit of the function as x approaches a exists. If these are satisfied, the limit of an nth power of a function is equal to the power of the limit of that function. Let's try this. The limit of the square of 2x minus 1 as x approaches 1. Applying the limit laws, we will have the square of the limit of 2x minus 1 as x approaches 1. Evaluating the limit, we will have 2 times 1 minus 1 squared. We will have 2 minus 1. Simplifying, we will have 1 squared. Hence, the limit of the square of 2x minus 1 as x approaches 1 is 1. The limit of an nth root of a function is the nth root of the function when evaluated at the value at which x approaches 2. However, we have to take note that the limit of an nth root of a function is equal to the principal nth root of the limit of that function, provided that n is a positive integer and the limit of the function is positive if n is even. Let's work on this example. Evaluate the limit of the cube root of 6x minus 27 as x approaches 0. Applying the law, we will have the cube root of the limit of 6x minus 27 as x approaches 0. Evaluating the function at x equals 0, we will have 6 times 0 minus 27. Simplifying further the radicand, we will get
the cube root of negative 27, which is equal to negative 3.
Therefore, the limit of the cube root of 6x minus 27 as x approaches 0 is negative 3.
Is the limit of the function always equal to f of a? Let's find out as we solve the next example. If f of x is equal to 2x squared plus 11x plus 5 all over x plus 5, find the limits of f of x as x approaches negative 5. Evaluating the function at x equals negative 5, notice that we will arrive at 0 over 0, which is an indeterminate form. To find the limits of the given function, we have to express the numerator in factored form so that we can cancel out similar factors. The function is then reduced to a much simpler form, which is 2x plus 1. Evaluating the function at x equals negative 5, we will get negative 9. Hence, the limit of f of x as x approaches negative 5 is negative 9. Remember that we can evaluate the limits of any algebraic function, polynomial, rational, or radical function by using one or a combination of the limit laws. If f of x is defined as a polynomial function, then the limit of f of x as x approaches a is equal to f of a. If f of x is defined as a rational function or a radical function, and a is in the domain of f, then the limit of f of x as x approaches a is equal to f of a. However, if f of x is defined as a rational function or a radical function and f of a is an indeterminate form, then we evaluate the limit of f of x as x approaches a by factoring or rationalizing f of x in order to cancel out all common factors between the numerator and the denominator, then applying the limit laws.